Dennis is from the Ukraine. A fun fact about him is that he likes Greek mythology and to reduce complexity. Are these mutually? I don't know. And his talk is about the sync package. Manage your own amusement park. Is that? No, wait. Is that? Yes. Yes. Okay. So we're going to have a talk about amusement parks now, and hopefully some Greek mythology references.
Okay, great. So let's start from some intro. When you want to build a program, you usually have some concept inside of your head. You completely understand what happens, so it looks like a corridor. So when the input will appear, you always can tell where will be the output. But when time goes by, program grows, extends, and one day it starts to look like a labyrinth. You can't tell anymore where will be the output. And humanity created patterns to manage that complexity. There are many types of those patterns, and one of the type is the concurrency patterns. And some of those concurrency patterns are already implemented in sync package. So what we have, real program that could look like a labyrinth, input data that could look like gophers, and sync package primitives like rules and features that we can apply to that labyrinth. And with all that resources, what we can do? I propose to build like an amusement park with one attraction, Labyrinth, where the gophers will be the visitors, so they're exploring the labyrinth and walking around, do some stuff. But to motivate those gophers, let's put something interesting inside. Let's put Minotaur, because what else you can put inside of the labyrinth? Okay, let's try to apply sync package to that situation. Let's imagine our gophers are walking around the labyrinth. They are trying to find Minotaur, they're trying to fight him and become the hero of the day, become popular. But what if two gophers found Minotaur simultaneously? Like, first one started the fight, what does another one have to do? I propose to isolate this section. That's a shared resource, and for that we have mutex with two methods, lock and unlock. So when we do the isolation, we actually call lock. We isolate the section, allowing them to fight. And after that, we can unlock that section, release the Minotaur, and allow anyone else start the fight again. Great. Let's imagine someone won the Minotaur. He became the hero of the day. His portrait goes straight to the hero of the day desk. He's popular. But that's easy to handle if we will have only one labyrinth. What if we want to scale? What if we want to build like many labyrinths? How we can choose the hero of the day? In that case. And for that, in sync package, we have once primitive, which has only one function do that can be called multiple times, but executed only once. So once someone won the Minotaur, he goes to the hero of the day. When another guy fought him, nothing happens. Great. So we have amusement park, we have hero of the day desk. So visitors are going around, they are watching the hero of the day desk. When we want to update that hero, like what can we do? Like it's a shared resource and someone is still watching. We could use mutex here, but that will require one-by-one access because it gives access only for the one. So for that, sync package has another kind of mutex, it's a read-write mutex with two additional methods, rlock and runlock. So once visitors start to watch the hero of the day desk, they call rlock. They are blocking that resource, but they can call rlock like simultaneously, and all of them will get the access, but only read access. And when they go out, when they stop watching, they call runlock, releasing that. But when our staff guy comes in, he wants to call lock. He wants to get on absolute power for the desk to update the hero. So for now, he don't even have read access. And to be fair, we don't have to let another visitors after him access too, because that will make infinite loop. So he won't be able to update never. Okay, so only after the last visitor will call runlock, our staff guy can lock, update the hero, and go out. And the process will be the same again. Okay, and many games in the world, they are popular because they allow you to play with friends, they have multiplayer. And we want to give that opportunity to you too, by giving you the tablet. The tablet will contain an empty map of that labyrinth, so when you will play with your friends, you will be able to explore simultaneously and fulfill that map from different sides of the labyrinth. But what would happen if you will try to update the same section of labyrinth simultaneously with your teammate? Some crash would happen. And to handle that, a sync package has map, which is a thread-safe version of the common map in a Golang. So great, we have some features, but we still have limited budget. We can give tablet for every new visitor to our labyrinth, and to handle that, we have pool, which has two methods, get and put. So once some visitor comes in, he calls get. He get tablet from one pool of tablets. Then he goes to explore some stuff, do something, and when that visitor will comes out, he will put the tablet back. So that's how we will be able to have only a finite number of tablets. Yeah. So, but even tablets, teammates do not guarantee that you will defeat and find and defeat the Minotaur. So, can we help our gophers to find the Minotaur? Also, they can lose track of time inside of the labyrinth while the exploration. So the security guy can get sanguine. And how can we handle those two problems? For that, we have cont with three methods: wait, signal, and broadcast. So let's imagine all of the gophers, when they come inside of the labyrinth, they go straight to the wait state. And when we want to help someone find the Minotaur, we just call the signal, which will reveal the whole map for someone inside with location of all items. So that will be only one guy from that wait queue. But when we want to notify everyone that it's time to go out, we can call broadcast. And that will reveal the whole map with the closest way out. So yeah, and even after notification, we can be sure that it's no one inside. Can we close labyrinth? And to be sure, we can use wait group. With three methods: wait, add, and done. So when someone comes in, they call add, whether it's add 1 or add 3, doesn't matter. And after that, when it's time to close, our security guy calls broadcast to notify everyone that it's time to go out. And he goes to the wait state. And when all visitors goes out, they call done, and when the last guy calls done, finally after that we can be sure that it's no one inside. And we can close it. So that was about theme package. I haven't mentioned local interface because it has the same method that Mutex has. That is my Twitter account, but I placed all the GIFs of that presentation. Thank you.
I'd love to see that as a screencast for on YouTube or something, because that would be a nice way to sort of educate people on some of those things, I think.
To show kids cartoons about going synchronization.